Dreams have fascinated humanity since we first developed the capacity for self-reflection. From ancient civilizations that viewed them as divine messages to modern neuroscientists mapping brain activity during sleep, dreams have remained one of consciousness's most persistent and beguiling mysteries. Consider this peculiar reality. Every night as you close your eyes and drift into unconsciousness, your brain will likely generate elaborate narratives featuring characters, emotions, settings, and plots. Complete sensory experiences that feel as real as waking life until the moment you awaken. Yet despite centuries of inquiry and decades of rigorous scientific investigation, we still cannot definitively explain why this happens. Our dreamscapes are simultaneously the most universal of human experiences and the most private. Each night, billions of people dream, yet each dream remains inaccessible to all but its dreamer. They are both mundane and profound, sometimes reflecting obvious daily preoccupations, other times producing insights or emotions that seem to emerge from the deepest wells of our being. Sleep itself is not a uniform state, but rather cycles through distinct stages. Dreams occur predominantly during rapid eye movement sleep, although some dream activity does occur in non-REM stages. During REM sleep, our brains exhibit electrical activity patterns remarkably similar to wakefulness. Blood flow increases, neurons fire rapidly, and our eyes dart back and forth beneath closed lids, as if watching the scenes unfolding in our minds. Meanwhile, our bodies enter a state of temporary paralysis, a fascinating evolutionary adaptation that prevents us from physically acting out our dreams. This paralysis, mediated by inhibitory neurons in the brainstem, disconnects motor commands from muscle activation, essentially transforming us into observers within our own mental cinema. Neuroimaging studies have identified key brain regions that become particularly active during dreaming. The visual cortex lights up, explaining the vivid imagery. The amygdala, central to processing emotions, particularly fear, shows heightened activity, which may account for the emotional intensity of many dreams. Interestingly, the prefrontal cortex, responsible for logical reasoning and executive function, exhibits decreased activity, potentially explaining why we accept the surreal logic of dreams without question until we awaken. Memory consolidation also appears intimately linked with REM sleep and dreaming. During sleep, the hippocampus replays the day's experiences, transferring short-term memories to long-term storage in the neocortex. This process seems to prioritize emotionally salient information, perhaps explaining why dream content often incorporates emotional concerns or significant recent experiences. Despite these insights, the fundamental question remains: are these physiological processes the purpose of dreaming, or is dreaming itself serving another function entirely? The theoretical landscape around dreaming broadly divides into two major camps, each with various subdivisions and nuances, but fundamentally differing on a central question: do dreams serve a primary biological function, or are they merely side effects of other brain processes? Those who advocate for dreams having a primary function view them as adaptive traits that evolved because they provided survival advantages to our ancestors. The competing view sees dreams as epiphenomena, essentially neural noise generated while the brain performs other important sleep functions like memory consolidation. In this view, dreams are the mind's attempt to create coherent narratives from random neural firing, similar to seeing shapes in clouds. The functional perspective: dreams as evolutionary adaptation. The threat simulation theory represents perhaps the most prominent functional explanation for dreaming. According to this view, dreams, particularly the anxiety-laden ones that seem so common, function as a biological defense mechanism, a virtual reality training ground where we can rehearse responses to threatening situations without actual danger. Early humans who dreamed of predators and practiced escape responses might have gained split-second advantages when encountering actual threats. The emotional systems activated during these dream scenarios could prepare individuals to respond more effectively to waking dangers. From this perspective, nightmares aren't unfortunate sleep disturbances, but valuable evolutionary tools, psychological fire drills preparing us for emergencies. Supporting this hypothesis is the observation that dreams frequently contain threatening elements and negative emotions, particularly anxiety. Children, who face more potential threats due to their vulnerability, experience a higher proportion of threatening dreams than adults. Cross-cultural studies suggest that people living in more dangerous environments report more threatening dream content. Other functional theories propose different adaptive benefits. Some suggest dreams serve as problem-solving mechanisms, allowing us to work through complications in a consequence-free environment. Others propose that dreams help regulate emotions by processing difficult feelings in safe contexts. Still others suggest dreams play a role in developing and maintaining social bonds by simulating social interactions and enhancing emotional intelligence. The common thread uniting these diverse functional theories is the assertion that dreams themselves provide an adaptive advantage, that our ancestors who dreamed effectively gained survival or reproductive benefits over those who didn't. The Epiphenomenon perspective: dreams as neural static. On the opposing side, proponents of the Epiphenomenon view argue that dreams themselves serve no particular function. Instead, they are byproducts of more important neural processes occurring during sleep. According to this perspective, REM sleep and the neurological activity it entails evolved for purposes unrelated to dream content, likely memory consolidation, neural maintenance, or other physiological functions. Dreams in this framework arise because our conscious mind attempts to impose narrative coherence on essentially random neural firing. As the brain consolidates memories, reorganizes neural networks, and performs general maintenance, these processes generate neural activity that stimulates various brain regions. The conscious mind, detecting this activity but lacking sensory input from the outside world, weaves these neural signals into the tapestry we experience as dreams. This explanation accounts for the often bizarre, disjointed nature of dreams. They appear strange precisely because they don't originate from logical thought processes, but from the mind's effort to interpret essentially random neural noise. The activation synthesis hypothesis, pioneered by Alan Hobson and Robert McCarley in the late 20th century, exemplifies this approach, suggesting that dreams result from the forebrain's attempt to make sense of random signals generated by the brainstem during REM sleep. Supporting the Epiphenomenon view is the observation that dreams frequently incorporate elements from recent experiences, the day residue effect, suggesting they reflect ongoing memory processing. Furthermore, dream content often seems random and meaningless rather than clearly adaptive, and many dreams are quickly forgotten, questioning their supposed importance. Beyond the binary integrated perspectives, the function versus epiphenomenon debate creates a compelling framework for discussion, but reality likely resides somewhere between these poles or perhaps transcends the dichotomy entirely. Contemporary dream researchers increasingly advocate for integrated models that acknowledge both the physiological processes underlying dreams and their potential psychological functions. The neurocognitive theory of dreaming, for instance, proposes that dreams emerge from normal cognitive processes operating under the unique neurochemical conditions of REM sleep. In this view, dreams reflect the same fundamental mechanisms that generate thoughts during wakefulness, but are shaped by the distinctive neurochemistry and activation patterns of the sleeping brain. Dreams might not have evolved specifically for their content, yet that content emerges from systems that themselves serve important functions. Another integrative approach, the continuity hypothesis, suggests that dreams reflect waking concerns and experiences, maintaining psychological continuity between sleep and wakefulness. Rather than serving a single function, dreams might contribute to multiple aspects of psychological well-being, helping process emotions, consolidate memories, and navigate social complexities simultaneously. Perhaps most intriguingly, dreams might serve different functions for different individuals, or even for the same individual at different times. The diversity of dream experiences, from mundane daily reflections to profound emotional journeys to lucid adventures where the dreamer gains awareness of the dream state, suggests that dreams might resist any single explanatory framework. Lucid dreaming, the conscious within the unconscious. The phenomenon of lucid dreaming, in which the dreamer becomes aware they are dreaming while remaining in the dream state, offers a fascinating window into dream consciousness. During lucid dreams, individuals can often exert some control over the dream narrative, manipulating dream content while maintaining awareness of the dream state. Neuroscientific studies of lucid dreamers have identified unique patterns of brain activity that distinguish lucid from non-lucid REM sleep. The prefrontal cortex, typically subdued during ordinary dreaming, shows increased activity during lucid episodes. This suggests the re-engagement of metacognitive awareness, thinking about thinking, within the dream state. Lucid dreaming challenges purely epiphenomenal explanations of dreams. If dreams were merely random neural noise interpreted by a passive consciousness, how could dreamers achieve awareness of the dream state and exert intentional control? The existence of lucid dreaming suggests at least some aspects of dream consciousness involve active cognitive processes rather than merely passive interpretation of neural static. At the same time, lucid dreaming doesn't necessarily vindicate purely functional theories either. The ability to become lucid may itself be an epiphenomenon, an interesting cognitive capability that emerged as a side effect of our complex consciousness rather than serving a specific evolutionary purpose. What lucid dreaming does unequivocally demonstrate is the remarkable flexibility of human consciousness. The boundaries between waking awareness and dream consciousness appear more permeable than once thought. This permeability hints at dreams' potential role in integrating various levels of consciousness, from the deeply unconscious to the fully self-aware. The hemispheric divide, dreams and brain lateralization. Human brains exhibit lateralization, a division of cognitive functions between the left and right hemispheres. Broadly speaking, the left hemisphere specializes in analytical, logical, and linguistic processing, while the right hemisphere excels at holistic, intuitive, and visuospatial thinking. This lateralization, while not absolute, provides another lens through which to examine dreaming. During REM sleep, the brain doesn't activate symmetrically. Studies suggest increased activity in the right hemisphere, or more precisely, the non-dominant hemisphere, since this pattern reverses in individuals with atypical lateralization. The right temporal lobe, involved in processing visuospatial information, music, and certain emotional content, shows particularly heightened activity. This hemispheric bias during dreaming might explain several characteristic features of dreams. The visual and spatial richness of dream environments aligns with right hemisphere specialization in visuospatial processing. The emotional intensity of dreams corresponds to the right hemisphere's role in emotional processing. Even the narrative structure of dreams, often metaphorical, associative, and symbolically charged rather than strictly logical, reflects right hemispheric thinking styles. The reduced activity in the left hemisphere during REM sleep might account for the typical absence of logical analysis within dreams. Without the left hemisphere's analytical oversight questioning inconsistencies, dreamers readily accept talking animals, impossible physics, and radical shifts in setting or identity. This hemispheric perspective offers insight into why dreams often provide creative insights and novel perspectives. By temporarily liberating thought from left hemispheric constraints, dreams may allow new connections between ideas, emotional processing unfiltered by rational censorship, and access to knowledge stored outside conscious awareness. Dreams across cultures, universal experience, diverse interpretations. While the neurobiological basis of dreaming appears universal across humanity, cultural contexts profoundly shape how people experience, interpret, and respond to their dreams. Anthropological studies reveal both striking similarities and profound differences in dream cultures worldwide. Certain dream themes appear nearly universal: being chased, falling, flying, being unprepared for an examination, losing teeth, or appearing in public inappropriately dressed. These common motifs suggest some aspects of dream content may derive from shared human experiences or possibly even innate neural patterns. Yet cultural differences in dream experience are equally apparent. Some cultures report predominantly outdoor dream settings, while others describe more indoor dreams. Certain cultures report higher frequencies of supernatural dream content. Even emotional patterns in dreams vary across societies, with some cultures reporting more aggressive dream content than others. More dramatic still are the differences in how various cultures interpret dreams. Many traditional societies view dreams as channels for communication with ancestors, spirits, or deities. Some Native American traditions regard dreams as journeys of the soul to other realms. Various Asian traditions see dreams as potential sources of divination or prophecy. Western psychological traditions, following Freud and Jung, often interpret dreams as expressions of unconscious desires or archetypal symbols. These divergent interpretations demonstrate how cultural frameworks shape not just our understanding of dreams, but potentially our experience of them. When individuals expect dreams to contain messages from ancestors, they may attend more closely to dream content that could be interpreted this way. When people believe dreams reveal repressed desires, they might notice and remember dreams with apparent sexual or aggressive content. This cultural dimension reminds us that dreams exist not just as neurological events, but as lived experiences embedded in social contexts. Any comprehensive understanding of dreaming must account for both universal neurobiological mechanisms and the rich diversity of dream experiences across cultures. Dreams as problem-solving creative insights during sleep. Throughout history, countless scientists, artists, inventors, and thinkers have attributed creative breakthroughs to dreams. Elias Howe's dream of cannibals with spears featuring holes in their tips inspired his critical innovation in sewing machine design. Auguste Kekule reportedly dreamed of a snake biting its tail, leading to his discovery of the benzene ring's structure. Paul McCartney has claimed the melody for Yesterday came to him in a dream. These anecdotes, while compelling, raise questions about how dreams might facilitate creative problem-solving. Several mechanisms appear plausible. During sleep, the brain continues processing information encountered during wakefulness, but under different neurochemical conditions. The reduced activity in the prefrontal cortex may allow more remote associations between ideas, connections that might be inhibited during waking analytical thought. The sleeping brain also appears to preferentially consolidate meaningful information while discarding less relevant details. This selective reinforcement might highlight essential patterns in complex problems, making solutions more apparent. Additionally, the metaphorical, visual nature of many dreams might enable representation of abstract problems in concrete forms that reveal new insights. Experimental evidence supports these anecdotal accounts. Studies show that REM sleep enhances creative problem-solving abilities. Participants allowed to sleep and dream between attempting difficult problems often perform better than those who remain awake, particularly on tasks requiring unconventional thinking or recognition of hidden patterns. This problem-solving capacity suggests dreams may serve an integrative function, weaving together disparate strands of knowledge and experience into new configurations. Rather than simply reflecting waking concerns, Dreams might actively contribute to addressing them, serving as incubators for solutions our waking minds cannot easily reach. The emotional workshop, Dreams as Psychological Processing. Dreams frequently contain strong emotions: fear, joy, sadness, anger, surprise, confusion. These emotional experiences can feel remarkably authentic, sometimes lingering into wakefulness and coloring our mood throughout the following day. This emotional intensity suggests dreams might play a crucial role in psychological processing. The emotional regulation theory proposes that dreams help process difficult feelings in a safe context. During REM sleep, emotional memories can be activated without the full stress response that might accompany them during wakefulness. This allows the brain to process emotionally charged experiences without overwhelming the system. Supporting this view, studies show that REM sleep helps reduce the emotional intensity of difficult memories over time. Dreams might facilitate this process by repeatedly activating emotional memories within a neurochemical environment that enables processing without psychological harm. The bizarre, metaphorical nature of dreams might allow emotional processing at a symbolic level when direct confrontation would be too disturbing. This emotional processing function appears particularly relevant for traumatic experiences. Post-traumatic nightmares, while distressing, might represent the brain's attempts to process trauma, gradually integrating overwhelming experiences into manageable narratives. Therapeutic approaches like image rehearsal therapy, which helps individuals reimagine recurrent nightmares with different outcomes, leverage this processing function to reduce nightmare frequency and intensity. Beyond processing specific emotional memories, dreams might also help maintain general emotional equilibrium. By simulating various emotional scenarios, dreams could function as a kind of emotional gymnasium where we exercise our capacity to experience, recognize, and respond to different feelings. This emotional rehearsal might enhance emotional intelligence and resilience in waking life. The emotional significance of dreams also explains why we remember some dreams but not others. Dreams with strong emotional content are significantly more likely to be recalled than emotionally neutral dreams. This selective remembering suggests the emotional processing function of dreams might be more important than any informational content they contain. Prophetic dreams, between coincidence and unconscious knowledge. Throughout human history, across virtually all cultures, people have reported dreams that seemingly predicted future events. These accounts range from the mundane, dreaming of an old friend before unexpectedly encountering them, to the dramatic, such as dreams apparently forewarning of accidents, natural disasters, or deaths. Modern scientific perspectives generally dismiss truly precognitive dreams as impossible, explaining apparent cases as coincidences, selective memory, or post hoc reinterpretations. With billions of people dreaming every night, some dreams will inevitably resemble subsequent events by pure chance. We tend to remember these hits while forgetting the vastly more numerous dreams that don't correspond to future occurrences. However, some seemingly predictive dreams might reflect unconscious knowledge rather than supernatural foresight. Our brains constantly process vast amounts of information, much of it outside conscious awareness. We notice subtle patterns, changes, and warning signs without consciously registering them. Dreams might sometimes bring this unconscious knowledge into awareness through metaphorical representation. For example, Someone might dream about a collapsing building before discovering structural problems in their home. Rather than supernatural premonition, this dream could reflect unconscious registration of subtle cues, unusual sounds, slight shifts in flooring, or small cracks, processed during sleep into a metaphorical warning. This unconscious processing might explain why intuitive hunches often emerge after periods of sleep. The sleeping brain appears particularly adept at integrating diffuse information and detecting patterns that escape waking analysis. When these insights surface in dreams, they can seem mysteriously prophetic when they actually represent sophisticated unconscious computation. This perspective allows us to appreciate the potential wisdom in dreams without requiring supernatural explanations. Dreams might indeed contain valuable warnings, insights, or predictions, not because they access mystical realms, but because they tap into the extensive unconscious processing our brains constantly perform. Nightmares, when dreams turn dark. While many dreams fall somewhere between pleasant and neutral, nightmares represent their disturbing counterparts, intensely frightening or distressing dreams that often cause awakening. Far from being merely unpleasant interruptions of sleep, nightmares offer particular insight into dream function and neuropsychology. From the threat simulation perspective, nightmares represent the system working as intended, generating scary scenarios that prepare us for real dangers. However, nightmares become problematic when they occur too frequently or intensely, suggesting a system operating beyond adaptive levels. Chronic nightmares, particularly in anxiety disorders or PTSD, might represent repeated attempts to process threatening information that remains emotionally overwhelming. Neurologically, nightmares involve hyperactivation of the amygdala, coupled with reduced activity in prefrontal regions that normally regulate emotional responses. This creates a state where fear proceeds unchecked by rational assessment, explaining why nightmare terrors can feel so immediate and overwhelming compared to waking fears. Interestingly, nightmare content often reflects evolutionary rather than contemporary threats. Modern humans frequently dream of being chased, attacked by animals, or falling, scenarios reflecting ancestral dangers rather than statistically more likely modern threats like car accidents or disease. This pattern suggests nightmare content may be partially shaped by evolved threat detection systems primed for dangers that threatened our ancestors. Recurrent nightmares present an interesting case study in dream function. They may represent incomplete processing of emotional material, the dreaming mind returning repeatedly to disturbing content it cannot fully integrate. Therapeutic approaches that address nightmare content directly, such as imagery rehearsal therapy, can reduce nightmare frequency and distress, suggesting that completing the processing these dreams attempt may resolve their recurrence. The existence of nightmares challenges purely epiphenomenal accounts of dreaming. If dreams were merely random neural noise, we would expect neutral emotional content to predominate. The prevalence of frightening dream content suggests dreams may indeed serve functions related to threat processing and emotional regulation, even when these processes become maladaptive. The architecture of dream landscapes, memory and imagination. Dream settings often feature impossible architectures, doors leading to unexpected places, buildings larger inside than outside, landscapes that transform without transition. Yet many dream elements clearly derive from waking experience, raising questions about how dreams combine memory and imagination. Memory clearly provides raw material for dreams. Dream settings frequently incorporate places we've visited, and dream characters often represent people we know, even if sometimes in disguised or composite forms. Day residue. The incorporation of recent experiences into dreams has been well documented since the earliest scientific dream studies. However, dreams rarely replay memories directly. Instead, they recombine memory elements in novel ways, blending disparate experiences into new scenarios. This recombination process appears central to memory consolidation, allowing the brain to extract general patterns from specific experiences and integrate new information with existing knowledge. The constructive nature of dream landscapes parallels the constructive nature of memory itself. Contemporary neuroscience recognizes that remembering involves reconstruction rather than simply retrieving fixed records. Each time we recall a memory, we essentially rebuild it, making it vulnerable to modification. Dreams might represent this reconstructive process in its most unconstrained form. The spatial navigation system centered in the hippocampus appears particularly active during dreaming. This might explain why spatial disorientation features prominently in many dreams. Locations shifting, impossible geography, doors leading to unexpected places. These spatial anomalies could reflect the hippocampus exploring navigational possibilities unconstrained by physical reality or testing spatial memory systems. Most intriguingly, dream architecture might reveal something about how our brains store and organize information. The strange transitions between seemingly unrelated settings might reflect underlying associative links between memory clusters. The appearance of familiar people in unfamiliar roles might reveal emotional or conceptual connections our conscious minds don't recognize. In this sense, dream landscapes might provide a window into the associative architecture of our memory systems. Dream characters, fragments of self or independent entities. Dreams populate our nights with an array of characters, some recognizable from waking life, others seemingly unique to the dream world. These dream figures raise fascinating questions about consciousness and identity. When we dream of other people, what exactly are we experiencing? From one perspective, dream characters represent aspects of ourselves, fragmented pieces of our own psyche, temporarily embodied in separate forms. Psychological approaches, particularly Jungian analysis, often interpret dream figures as personifications of our own traits, desires, fears, or unacknowledged aspects of personality. The wise elder in your dream might represent your own untapped wisdom. The threatening pursuer might embody fears you're running from in waking life. Supporting this view is the observation that dream characters emerge from the same brain as the dreamer's self-representation. Logically, they must derive from the dreamer's own neural activity, rather than representing truly independent consciousnesses. However, experienced dreamers often report that dream characters display surprising autonomy. They may provide information the dreamer didn't consciously know, express viewpoints opposed to the dreamer's waking beliefs, or behave in ways that feel genuinely unexpected. Particularly in lucid dreams, interacting with dream characters can feel remarkably like engaging with independent minds. This apparent independence might reflect the modular nature of consciousness. Rather than being a unified phenomenon, consciousness likely emerges from multiple semi-independent neural systems working in concert. Dreams might temporarily decouple these systems, allowing different aspects of mind to manifest as separate characters with their own apparent autonomy and perspective. Particularly intriguing are cases where dream characters provide solutions to problems the dreamer couldn't solve while awake. Rather than supernatural intervention, these instances might represent access to knowledge stored in brain systems not directly available to waking consciousness. By embodying these systems as separate characters, dreams might enable different parts of our minds to communicate with each other. The social simulation perspective offers another view of dream characters. According to this approach, dreams serve partly to rehearse social interactions and develop social skills. Dream characters would then represent the brain's best models of how other people might behave, allowing us to simulate social scenarios and their potential outcomes. Dreams and mental health. Windows into well-being. The relationship between dreaming and mental health runs deep. Dream patterns often change during psychological distress, and certain dream characteristics correlate with specific disorders. Simultaneously, dreams themselves can influence mental states, sometimes exacerbating difficulties but potentially also contributing to healing. Depression frequently alters dream content and recall. Depressed individuals typically remember fewer dreams, but report more negative dream content when they do recall dreams. The emotional tone of dreams often mirrors waking mood, potentially reinforcing negative emotional states. Anxiety disorders commonly manifest in dream content, with anxious individuals reporting more threatening dreams. In generalized anxiety disorder, everyday concerns often appear in exaggerated dream forms. Social anxiety may generate dreams of embarrassment or rejection. These anxiety dreams might reflect the disorder itself or represent attempts to process anxiety in a safe context. Post-traumatic stress disorder presents perhaps the clearest connection between dreams and mental health. Traumatic nightmares, often realistic replays of traumatic events, constitute a core symptom of PTSD. These nightmares differ from ordinary bad dreams in their realistic content, resistance to modification, and tendency to awaken the sleeper. They appear to represent incomplete emotional processing of trauma, with the dreaming mind repeatedly returning to overwhelmingly frightening content it cannot integrate. Beyond reflecting psychopathology, dreams potentially contribute to psychological healing. Dream work in psychotherapy, exploring dream content for insights into unconscious processes, has a long history. While early psychoanalytic approaches emphasized uncovering repressed material, contemporary therapeutic uses of dreams often focus more on using dream imagery as a resource for addressing waking concerns. Several therapeutic approaches directly target dreams themselves. Imagery rehearsal therapy teaches nightmare sufferers to reimagine disturbing dream content with different, empowering outcomes during wakefulness. This reimagining often transfers to subsequent dreams, reducing nightmare frequency and intensity. Lucid dream therapy helps individuals recognize dream states and modify frightening content while dreaming. Both approaches have shown effectiveness in reducing nightmare-related distress. The relationship between dreams and mental health suggests that dreaming serves important psychological functions. Rather than mere neural noise, dreams appear intimately connected with emotional processing, psychological integration, and potentially healing. How we dream both reflects and influences our psychological well-being, creating a bidirectional relationship between dream life and mental health. The neuroscience of dream loss. What happens when we don't dream? Certain conditions and substances can suppress REM sleep and, consequently, dreaming. Studying these situations offers another window into dream function by revealing what happens when this natural process is disrupted. Many antidepressant medications, particularly selective serotonin reuptake inhibitors, SSRIs, substantially reduce REM sleep. Alcohol, while initially seeming to promote sleep, actually disrupts normal sleep architecture, particularly suppressing REM during later sleep cycles. Certain neurological conditions and brain injuries can also selectively impair REM sleep mechanisms. The consequences of dream suppression appear complex and incompletely understood. REM sleep reduction from antidepressants doesn't seem to cause significant cognitive or emotional problems. Indeed, these medications improve mood despite reducing dreams. This observation challenges strong versions of theories claiming dreams serve essential psychological functions. However, REM suppression does have consequences. REM rebound, a significant increase in REM sleep following periods of suppression, suggests the brain prioritizes recovering lost REM sleep, indicating its importance. Animal studies show that extreme prolonged REM deprivation can cause irritability, anxiety, and difficulty concentrating, though these effects might stem from sleep disruption generally rather than specifically from dream loss. Most intriguingly, REM suppression appears to affect emotional processing. Studies suggest that learning emotional material before sleep leads to better emotional integration if followed by undisturbed REM sleep compared to REM suppressed sleep. This supports theories that dreams contribute to emotional regulation and memory consolidation, particularly for emotionally charged experiences. The absence of catastrophic effects from medication-induced dream reduction suggests dreaming may represent an overdetermined system, one where multiple mechanisms contribute to the same essential functions. When dreaming decreases, other neurological processes might partially compensate. Alternatively, dreams might enhance functions that remain adequate but suboptimal without them, creating subtle deficits not easily detected in clinical observation. Teenage dreamers frequently report dreams involving peers, social evaluation, and identity exploration. Dream anxiety commonly centers on social acceptance, competence, and autonomy. This shift mirrors adolescents' waking preoccupations with identity formation and social position. Adult dreams show the greatest complexity and diversity, encompassing elaborate narratives, metaphorical content, and emotional nuance. Working-age adults frequently dream about professional activities and responsibilities, while parents often dream about their children's welfare. Romantic relationships and unresolved conflicts commonly feature in adult dreams across cultures. Elderly individuals typically report fewer dreams, corresponding with reduced REM sleep in later life. However, dream recall varies greatly among older adults, with some maintaining vivid dream lives into advanced age. Dreams in healthy older adults often involve life review themes with increased appearances by childhood figures and decreased anxiety compared to younger adults. This developmental progression suggests dreaming adapts to changing psychological needs across the lifespan. Rather than serving a single fixed function, dreams might contribute differently to well-being at different life stages, supporting neural development in infancy, identity formation in adolescence, emotional regulation in adulthood, and life integration in old age. Conscious creation, lucid dreaming practices and potentials. Lucid dreaming, the state of becoming aware that one is dreaming while remaining in the dream, transforms the typically passive dream experience into a potentially active, constructive process. This fascinating phenomenon raises tantalizing possibilities for both scientific investigation and personal exploration. While spontaneous lucidity occurs naturally for many people, various techniques can increase lucid dream frequency. Reality testing involves regularly questioning whether one is awake or dreaming during wakefulness, eventually carrying this habit into dreams. Mnemonic induction techniques involve setting strong intentions to recognize dream states while falling asleep. Wake back to bed methods interrupt sleep in the early morning hours before returning to bed, often inducing lucidity during subsequent REM periods. Scientific verification of lucid dreaming relied on ingenious protocols developed in the late 20th century. Researchers instructed experienced lucid dreamers to signal upon achieving lucidity by making specific eye movement patterns, movements that could be detected on electrooculagrams despite REM sleep paralysis. These studies conclusively demonstrated that individuals could indeed achieve consciousness of the dream state while physiologically remaining in REM sleep. The applications of lucid dreaming span both psychological and creative domains. Therapeutically, lucid dreaming enables direct engagement with nightmare content, allowing dreamers to confront and transform frightening scenarios. Some evidence suggests lucid dream interventions can reduce nightmare frequency and severity in both PTSD patients and those with idiopathic nightmares. Creatively, lucid dreams offer unique environments for artistic exploration and problem-solving. Artists, writers, and musicians report using lucid dreams to experiment with creative ideas, develop characters or melodies, and overcome creative blocks. The dream state's freedom from physical constraints and enhanced access to associative thinking appears particularly conducive to creative exploration. More speculatively, lucid dreaming might offer opportunities for skill development through mental practice. While physical movements remain inhibited during REM sleep, the neural circuits activated during dreamed practice partially overlap with those involved in physical performance. Some preliminary evidence suggests mental rehearsal in lucid dreams might complement waking practice for certain procedural skills. The existence of lucid dreaming reminds us that consciousness exists on a spectrum rather than in binary states. Between fully unconscious sleep and complete wakefulness lies a fascinating continuum of aware states, each offering different relationships between conscious intention and spontaneous mental activity. Lucid dreaming represents one such hybrid state, combining the hallucinatory experience of ordinary dreaming with aspects of waking metacognition. Dreams and consciousness. Philosophical implications. Beyond their neurobiological and psychological aspects, dreams raise profound philosophical questions about the nature of consciousness, reality perception, and personal identity. Dreaming represents a natural, altered state of consciousness experienced by virtually all humans, a universal form of hallucination we accept as normal. Dreams challenge simplistic models of consciousness as merely awareness of external reality. During dreaming, we experience something that feels unquestionably real while bearing no direct relationship to physical surroundings. Only upon awakening do we typically recognize the dream's constructed nature. This observation raises questions about waking consciousness itself. How can we be certain our waking perceptions aren't similarly constructed rather than directly accessing objective reality? The vivid experience of selfhood within dreams complicates philosophical concepts of personal identity. In dreams, we sometimes embody entirely different identities, different genders, ages, species, or personalities, yet subjectively experience these alternate selves as authentically me. This suggests personal identity might be more fluid and constructed than our waking experience indicates. Dreams also illuminate the relationship between belief and perception. While dreaming, we typically accept bizarre scenarios without question. Talking animals, impossible physics, sudden transformations. Only in lucid dreams does critical evaluation of these elements occur. This acceptance hints at the primacy of perception over rational analysis in shaping our experience of reality. We believe what we perceive before questioning its plausibility. The phenomenon of false awakening, dreaming that one has awakened while actually remaining asleep, raises particularly intriguing questions about consciousness. During false awakenings, dreamers believe they have returned to waking reality, sometimes performing normal morning routines or describing dreams to others, only to eventually awaken and realize these experiences themselves occurred within dreams. These experiences suggest our sense of being awake represents another mental state that can be convincingly simulated rather than an objective recognition of external reality. Perhaps most profoundly, dreams demonstrate that our brains can generate complete experiential worlds independently of sensory input. This generative capacity suggests consciousness might be fundamentally creative rather than merely receptive, actively constructing rather than passively reflecting reality. Integrating perspectives toward a unified understanding. After exploring diverse approaches to understanding dreams, from neurobiological mechanisms to evolutionary functions to cultural interpretations, we might wonder whether these various perspectives can be integrated into a cohesive framework. Rather than competing explanations, perhaps these different approaches illuminate complementary aspects of a complex phenomenon. Dreams likely serve multiple functions simultaneously, operating at different levels of analysis. At the neural level, they might facilitate memory consolidation and network maintenance. At the psychological level, they might aid emotional processing and problem solving. At the social level, they might enhance interpersonal understanding and cultural transmission. Each function need not exclude others. The apparent tension between functional and epiphenomenal views might resolve through recognition that dreams represent emergent phenomena arising from processes that evolved for various purposes. The specific content of dreams might be largely epiphenomenal, a side effect of underlying processes, while simultaneously serving important psychological functions through its very experience.